you live right here. It's the baseline for everything you know, your house, your neighborhood, your entire perception of distance. And if we look out to the moon, our closest celestial neighbor, the gap doesn't look that intimidating. It feels like a quick trip next door. But at their farthest point, Earth and the moon are separated by 252,088 miles. A gap so vast, you could stack Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune end to end inside it. Our brains simply struggle to process spatial reality. Even the smallest physical gap in our own local backyard easily defies human intuition. Now look at volume. Take the Great Red Spot on Jupiter. That single atmospheric storm is roughly 2 times the size of our entire planet. Saturn itself is 9 times wider than Earth. And those iconic rings are so massive that some of the individual fragments tumbling within them are the size of actual mountains. If you stood on the surface of Mars or hovered right behind Saturn's rings and looked back at Earth, you would barely see us. Push out even further to a perspective just beyond Neptune, 4 billion miles away. From that vantage point, our entire world, every ocean, every continent, every person, is reduced to a single, indistinguishable speck of light in the dark. We throw around numbers like a billion all the time, but the human mind is generally terrible at understanding math at that scale without a translation. This chart shows that difference in time. 1 million seconds will pass in about 11.5 days. 1 billion seconds will take over 31 years. Apply that recalibrated scale to our sun. Compared to the Earth, the volume of our local star is completely terrifying. Yet there are stars out there that make our sun look incredibly small. The hypergiant star VY Canis Majoris is roughly 2,000 times the diameter of our sun. As Carl Sagan once observed, the total number of stars in the universe is larger than all the grains of sand on all the beaches of the planet Earth. Our massive, imposing sun is actually a wimpy, completely average participant in a wildly crowded stellar population. Moving past individual stars to look at the Milky Way galaxy, miles and kilometers stop working. We have to start using light years. To make sense of this, imagine shrinking our entire solar system down until it is exactly the size of a physical quarter. On that exact same scale, the diameter of the Milky Way spans the geographic footprint of the United States. It's 100,000 light-years wide, or roughly 621 quadrillion miles. And even then, our galaxy is a runt. A spiral galaxy like NGC 6744 stretches 200,000 light-years across, doubling our size. Point a lens like the Hubble Space Telescope into the darkest patches of the sky, and you capture thousands and thousands of galaxies in a single frame, each containing millions or billions of their own stars and planets. Some of the objects in those deep space images formed as many as 11 billion years ago, during one of the busiest star-forming periods, just 3 billion years after the Big Bang. The deepest, most chaotic slice of space we have ever managed to photograph is still just a microscopic, localized fraction of the whole universe. Now, pull all the way back from those 11 billion-year-old macrostructures and return to your actual modern daily life. You probably get incredibly frustrated when a network cancels your favorite television show, or when a store starts playing retail Christmas music way too early in the season. We let these tiny frictions ruin our day, completely ignoring the quadrillions of miles of silent void and ancient burning gas that surround us on all sides. Realizing your absolute physical insignificance doesn't have to be a tragedy. It's actually a massive relief. The universe is incredibly large, which means your everyday problems are wonderfully small.